Hi students, I wanted to make a video to go over the Nursing 120 dosage calculation packet. I've had a few questions about it, so I want to try to answer some of those. So first I want to look over here at the dosage calculation practice exam. On the practice exam you have instructions for rounding, and you will have those instructions on the exam. So just make sure you follow those, but it's not something you need to memorize. Conversions you do need to memorize, as far as like milligrams to micrograms to kilograms, teaspoons to milligrams, those kind of things you do need to memorize. So if we go on to our first problem, I'm going to try to split screen here. So our first problem says that we have heparin 4,000 units subcutaneous daily. The label, which means the medication we're getting from the pharmacy. So when we look at the bottle of medication from the pharmacy, it says that the medication is heparin 5,000 units, and that's contained within half a milliliter. So when I look at these problems, I always start at, what equation do I already know? And the equation I already know is 5,000 units per half ml. So when I worked it out over here, I changed that half to 0.5. 5,000 units over 0.5 milligrams. And then the other information that I do know is 4,000 units, but I need to know how many milliliters, 0.5 milliliters. And so then I put 4,000 units, and I need to know how many milliliters is going to be in 4,000 units. So you can work these problems any way that you want to. This is the formulas that I use to get the answers to the problems, but you can use dimensional analysis, you can use a couple of other methods, but I'm going to just show you the way that I do it. So I would cross multiply at that point, and I get 5,000 x equals 2,000, x equals 0.4 milliliters. So that would be how much medication that we would draw up in our syringe to give to our patient in order for them to get 4,000 units of heparin with that injection. The second one says a client is to receive Humulin R insulin 6 units per hour as a continuous drip. The solution concentration is Humulin R insulin, 50 units per 500 ml of normal saline. Calculate milliliters per hour for an infusion pump. So what this is saying is that we not only can give insulin as a subcutaneous injection, we can also give it as a continuous IV drip. And we would do that if somebody's blood sugar was really high and they came in with DKA or something like that. So we wouldn't be mixing this ourselves. Many years ago we did. This is already going to come from the pharmacy to us pre-mixed. So the bag that we're getting from the pharmacy is going to say that there's 50 units of Humulin R per 500 ml of normal saline. Our order from the doctor is going to be, they want a continuous drip going of Humulin R at 6 units per hour. So when we look at this bag from the pharmacy, we would need to know how to program the IV pump in order for that patient to get 6 units of that medication per hour. So that's what we're trying to figure. So what we would do is, again, take what we already know. I already know that 50 units is 500 ml because that's on our IV bag that the pharmacy has prepared for us. The other information I know is that I need 6 units per hour. So if 50 units are in 500 ml, I need to know how many milliliters need to be given to be the equivalent of 6 units per hour. So take what you know over here in number 2. I know 50 units per 500 ml. I also know 6 units. I need to know how many mLs is in 6 units. I cross multiply and get 50x equals 3,000. And then when I divide 50 into 3,000, I get 60 milliliters per hour. So I need to program that pump at 60 milliliters an hour in order for that patient to be getting 6 units an hour of that fluid, to give them 6 units an hour of Humulin R insulin. Does that make sense? Okay. Number 3 says Dilaudid is available as 10,000 micrograms per 100 ml, and it's given in 0.9% sodium chloride. 0.9% sodium chloride is normal saline. The order indicates Dilaudid at 0.6 milligrams an hour via infusion pump. Calculate for milliliters per hour. Again, we need to know how to program an IV pump. An IV pump, the infusion is going to be going at milliliters per hour. This is another instance where usually we give Dilaudid, which is a pain medication, IV push, or we can give it as an IM injection. But if we were to have a patient maybe that was terminally ill or that needed a high dose of pain medication, they may give it in a continuous infusion so that patient would have constant pain relief. So this is another instance where we were getting that bag of medication from the pharmacy already pre-mixed. That bag has 10,000 micrograms per 100 mLs of normal saline. That's our bag we're looking at. It's labeled that way. But I'm only going to give 0.6 milligrams an hour, and I need to know how to program that IV pump to give that much medication per hour. So over here, again, we take what we already know, 10,000 microgram over 100 milliliter. The first thing I notice when I'm looking at number 3 is that I'm dealing with different units of measure. I'm dealing with a microgram and a milligram. So I go ahead and change those right away. What comes from the pharmacy, that 10,000 micrograms per milliliter, per 100 milliliter, is going to stay the same. Okay, because that's my given, that's what I know. So I went ahead and changed 0.6 milligrams to 600 micrograms. And I did that by multiplying 0.6 by 1,000 and getting 600 micrograms. So 10,000 milligrams over 100 milliliters equals 600 micrograms over how many milliliters? And again, I cross multiply. I need to know how many milliliters an hour. So when I cross multiply, I get 10,000x equals 60,000. I divide 10,000 into 60,000 and I get 6 milliliters per hour. So that's what I'd want to set the pump at. Number 4 says, excuse me, enoxaparin 900 milligram vials are available. So many times we give medications that come in a powdered form, and they do this because they're not stable as a liquid, which means once we make them into a liquid that they have to be used immediately. So they're stored as a powder because in their active form they're not as effective over time. So this is one of those medications. Enoxaparin is Lovenox, and it's given to prevent blood clots. So in its powder form, we have a vial of 900 milligrams. And in order to make that into a form that I'm able to inject into the patient, it needs to be a liquid, right? So on the vial it says how many milliliters of liquid, in this case sterile water, I have to inject into that bottle, mix with the powder, again rotate it between our hands and mix them together to make a concentration. Once I add that 2.8 milliliters of sterile water, the concentration it yields is going to be 300 milligrams per 3 milliliters. That's not something that you have to figure out. That's going to say on the bottle. So that's not something we have to try to figure out. We're going to look at the bottle again. It's going to say how many milligrams is in that powder. It's going to give us instructions on the bottle that says how many milliliters of fluid and what type of fluid we add to it. And then it's going to give us our concentration. So that concentration is a given. That's what we already know. My patient is to receive enoxaparin 30 milligrams every 12 hours following a total left knee replacement surgery. How many milliliters will the nurse administer subcutaneously each time? So I need to know how many milliliters I'm going to draw up in my syringe. Again, at this point, my given is 300 milligrams per 3 milliliters. So in my equation over here, I take my given, 300 milligrams over 3 milliliters, and that's going to equal the 30 milligrams. I need to figure out how many milliliters that I need to draw up in my syringe. So I cross multiply. I get 300x equals 90. I divide 300 into 90 and I get 0.3 milliliters. That's going to be the amount of this Lovenox that I draw up into my syringe in order to ensure my patient is getting 30 milligrams per injection. Okay? So let's go on to number 5. Number 5 says, a physician orders ampicillin 500 milligrams every 6 hours, IV piggyback for pneumonia. So we're going to be hanging a small piggyback as a secondary bag on our IV pump. And when you do this, in the semester, it'll become more familiar to you. The drug is available as 2 grams over 1.5 milliliters. Drug literature states to mix in 50 milliliters of normal saline and deliver over 30 minutes. So we're going to calculate 2 different things for this equation. We need to calculate the amount of medication that we need and determine the flow rate for an IV piggyback infusion. So we're going to have to calculate the amount of medication that we need and also what we're going to program the pump at, how many milliliters an hour to infuse this. So 2 things we're looking at. So for number 5, I'm going to take my given again. What's my given? Well, I know that I have 2 grams per 1.5 ml. So at this point, again, we're looking at different units of measure. I'm looking at 2 grams versus 500 milligrams. So you could do this either way. You can change grams to milligrams or milligrams to grams, just so you're dealing with the same units of measure. I went ahead in this case and changed it to 2,000 milligrams instead of the 2 grams in my equation. So I've got 2,000 milligrams over 1.5 ml. I need to know how many milliliters is in this 500 milligram. So I've got the same equation with 500 milligrams over how many mLs. Cross multiply and I get 2,000x equals 750. When I divide 2,000 into 750, I get 0.38 milliliters. So that's going to be the amount of medication that I need. But how do I program the pump? So programming the pump, I'm going to take that's the amount of medication that's going to be mixed with the normal saline to get this IV piggyback bag. That's going to be done by the pharmacy. But we want you to know how to figure that, because there may be an instance where you still have to do that. So this 0.38 milliliters is the amount of medication, the amount of ampicillin that is going to be added to this 50 milliliter bag to give this to the patient, okay? So we know that we're going to give this 50 milliliters over 30 minutes, okay? So the 50 milliliter bag we're giving over 30 minutes, and I need to know how to program the pump. So the pump is set up to program how many milliliters per hour. So that's simply what I'm figuring now. If 50 milliliters go in a half an hour, how much is going to go in an hour? So that's 100 milliliters per hour. Now we would program the pump at 100 milliliters an hour, but when we put in our volume, we would only be putting 50 milliliters an hour. So that would ensure that our medication is going to be going in over half an hour. Does that make sense? Someone asked me earlier, they had a good question and said, okay, if I'm mixing the 0.38 milliliters with 500 milliliters for the normal saline bag, why is my volume still 50 milliliters? Well, it is because we're dealing with a very minute amount of medication. So instead of changing it to 50.38 milliliters, it simply is still the amount of volume that's in the bag. That's what we're going to be using to calculate with. So 50 milliliters is what we're going to be dividing, because even when we add our medication to that, that's still going to be the volume of the bag. It always is. So let's look at number 6. Number 6 is going to be 1 liter of D5W contains 20,000 units of heparin. Okay, so we know we have a bag of IV fluid that has had heparin added to that, and we're going to infuse that bag over 30 milliliters an hour. We want to calculate the dosage of heparin the patient is to receive per hour if it's going at 30 milliliters an hour. So one thing that I look at and I notice when I read this problem is 1 liter of D5W. Well, I have to know how many milliliters that's going to be, because we're dealing with different units of measure. So instead of 1 liter, I automatically go ahead and just change that on my paper to 1,000 milliliters. So I've got equal units of measure that I'm looking at. So what do we know? We know that there are 20,000 units in, again, 1,000 milliliters. So that's my given. That's what I start my problem with. And I need to know how many units of medication are going to be infused if it's going at 30 milliliters an hour. So kind of a little backwards from what we looked at earlier. So when I cross multiply, I get 1,000x equals 600,000. And I divide those. I divide 1,000 into 600,000, and I get 600 units per hour. So 600 units an hour is how much my patient is going to be getting if it's going at 30 milliliters an hour. Number 7 says the order reads fentanyl 0.5 micrograms per kilogram IV now. The patient weighs 280 pounds. Fentanyl is supplied in a vial labeled 0.05 milligrams per milliliter. How many milliliters will the nurse administer? So we have to look at this problem and know that if I have a problem that's dealing with micrograms per kilogram, I have to have my weight as a kilogram. So the first thing I need to do is change my 280 pounds into kilograms. So I showed that in my work over here. I did 280 pounds equals how many kilograms, because I already know that 2.2 pounds is 1 kilogram. So when I cross multiply, I get that X is 127 kilograms. So this 280 pounds is equivalent to 127 kilograms. So then I can use that put it into my equation to answer the problem. So what's our given? Our given is going to be, we know the weight, and I go ahead and plug it into this because I know how many micrograms. They have to be divided by kilograms, and now I know my kilograms, so that's going to be a given that I already know. So I can write that over here. So we know that I have 0.05 milligrams per milliliter. When I have 0.05, up here, the 0.05 micrograms per kilogram. So I want to plug that in. So if I know 0.5 micrograms is 1 kilogram, how many micrograms are going to be in 127 kilograms? Because it says here 0.5 micrograms per kilogram. So if I have 127 kilograms, the number of micrograms is going to be 63.5 micrograms. Okay? So this equation that we're looking at over here, this 0.5 micrograms per kilograms, I could just put a line through that, and that is going to equal my 63.5 micrograms at that time. I can then take that, because if we're looking at milliliters. How much milliliters will we administer? I don't know the milliliters yet, so I haven't gotten to my end part of the equation. So I need to be able to solve for this, the 0.05 milligrams per milliliter. So I've got my 63.5 micrograms, and we need to know how many milliliters that is. So I'm going to take this 0.05 milligrams, and I need to have equivalent units of measure again. So since we know that 63.5 micrograms takes the place of this equation, I change this to micrograms as well, because we have to have equivalent units of measure. So instead of 0.05 milligrams, I changed it to 50 micrograms. Again, I took this and I multiplied it by 1,000. So I got 50 micrograms. So I take the 63.5 micrograms over X, because I already know that 50 micrograms is going to be 1 milliliter right here. I can just say that 50 micrograms is 1 milliliter. I'm going to cross multiply again. I get 50x equals 63.5. And then when I divide 50 into 63.5, I get 1.3 milliliters. So that 1.3 milliliters is going to be how many that I will administer. Okay. Number 8, a client weighs 165 pounds. Administer a bolus of heparin sodium IV at 18 units per kilogram per hour. A bolus solution is going to be, again, something that I would put into an IV bag. So it's asking, I've got to figure out how much of this heparin I'm going to put into 1 liter of normal saline. So a normal saline bag. So it tells us that 1 liter of normal saline has 25,000 units of heparin. So that's what's going to come from the pharmacy, and it's going to have a label on there. A normal saline bag with 25,000 units of heparin has been added to it. But it doesn't tell me what I need to set the pump at, how much I'm going to infuse into this patient per hour. So again, that's what we're looking at. I need to look at equivalent units of measure. I don't have the kilograms. I need to figure that out from the pounds. That's the first thing I do, is change my pounds to kilograms. So over here, I change my 165 pounds to kilograms by cross-multiplying, and I get 75 kilograms. And then again, I take that and I plug it into this equation that's going to give me more information. Excuse me. So once I get this 75 kilograms, I know that I need 18 units per kilogram per hour. So if 18 units equals 1 kilogram, how many units is in my 75 kilograms? How many units will I give for 75 kilograms? And when I cross multiply, I'm going to get 1,350 units. But is units what I'm looking for? No, I haven't gotten far enough yet. So I need units to solve my equation. And that equation is going to be the 25,000 units over the 1 liter, or 1,000 milliliters. And I change it to milliliters because milliliters is ultimately the answer that I'm looking for. So I take this that's given, the 25,000 units over 1,000 milliliters, and I know that I need my patient to get 1,350 units, but I need to know how many milliliters that is per hour. So I'm going to cross multiply, and I get 25,000x equals 1,350,000. When I divide that, I get 54 milliliters per hour. That's going to be what I program into my IV pump. That is going to enable my patient to get this 18 units per kilograms per hour for that patient. Does that make sense? Number 9 says IV Bactrim, which is an antibiotic, 500 milligrams every 12 hours. My patient weighs 125 pounds. The recommended dosage is 6 to 12 milligrams per kilograms per day, divided every 12 hours. So we've got a couple of things we're looking at. Using the nursing process, what decision will you make regarding this medication order? So I don't know if that medication order for my patient's weight is safe until I work out the math on that. So that's what it's asking. It's asking to work out the math two different ways. We're going to get a range. We're going to work it out for 6 milligrams per kilogram per day, and we're going to work it out for 12. And that's going to give us our range to see if the dosage that we've been ordered, those 500 milligrams every 12 hours, is in the range that's a safe medication dose for our patient. So first, again, I've got kilograms and pounds, so I need to get rid of my pounds. I'm going to change 125 pounds to kilograms, and I cross multiply, get 57 kilograms. And then I need to plug it into this equation here to find out how much medication that is. So I'm going to do it twice. I'm going to do it once with 6 milligrams and once with 12 milligrams. That's going to give me a range of medication. So I've got 6 milligrams divided by 6 milligrams multiplied by my 57 kilograms. 6 milligrams per 57 kilograms. When I multiply that, I get 342. But what the answer that it's given us is going to be 342 milligrams per day. I need to know every 12 hours, so that's why I divided it by 2. So it's asking us here to look at the dosage. So if I need to know again every 12 hours, I've got to divide that per day by 2 to give me 2 doses per 24 hours. Okay. So I divided it by 2. I got 171 milligrams every 12 hours. And then when, excuse me, when I went back and worked that with the 12 milligrams multiplied by 57 kilograms, I got 684. And again, I divided by 2 for every 12 hours, and I got 342 milligrams every 12 hours. So that's going to be our range. 171 milligrams to 342 milligrams every 12 hours is going to be a safe dose for our patient. My physician wants to order IV Bactrim at 500 milligrams every 12 hours. So is that a safe dosage? It's too high, isn't it? So for this one, the dosage ordered is too high, and I would need to consult the physician. Number 10. The nurse has received an order for Humulin R insulin 0.05 units per kilogram per hour for a patient weighing 100 kilograms. The IV solution contains 100 units Humulin R insulin and 500 milliliters per normal saline. Determine the rate for which the IV pump will be programmed. Okay, this is similar to what we did before. We're trying to figure out, based on my patient's weight, how much solution they should be given. So I know that my patient's 100 kilograms. For this one, we're already given the kilograms. And we received an order from the physician at 0.05 units per kilograms per hour. So in order to figure out even how much medication I need to give my patient, I need to plug in that 100 kilograms into that equation. So that's what I did. I plugged in 0.05 units. I multiplied it by the 100 kilograms, and I got 5 units. So when I get my 5 units, I need to put it into the equation that I know. The IV solution contains 100 units Humulin R insulin and 500 milliliters of normal saline. That's the IV bag again that's sent from the pharmacy that tells us this is how much insulin we've added to this normal saline bag of fluid. So what I will do is take that 5 units and figure out how much of that I need to program for my patient to give. So I will take what I know, 100 units in 500 ml, and what I figured out before is my patient needs to get 5 units, but I need to know how many milliliter that's going to be. So I'll cross multiply and I get 100x equals 2,500. When I solve for x, I get 25 milliliters per hour, because remember over here we talked about its units per hour. So my 25 milliliters per hour is how much I need to set the IV pump at in order for my patient to be infused with 5 units of heparin per hour. Okay. Number 11. A client weighing 70 kilograms receives 5 milligrams per kilogram of Zovirax, which is also a cyclovir sodium. It's an antiviral medication, and it's going to be diluted in normal saline as well. So they're putting it into the IV bag, and it's going to be in a bag that has 100 milliliters of normal saline, and we're going to give it every 8 hours. So one of these bags is going to be sent to us every 8 hours for the patient, and it's given as an IV piggyback. So that means it's a small bag that we'll be delivering to the patient. The IV administration set delivers 15 drips per milliliter. So this is one of these that have drip calculations that we have to figure. Based on literature, the nurse knows this drug should be given at a constant rate over 1 hour. Now, what literature are they talking about? That's going to be our drug book. Okay, so if we were to look this up in our drug book, it would tell us for Zovirax that we need to give it, if it's in 100 milliliters, we need to give it at a constant rate over an hour for that medication to be a safe medication dosage for our patient. I need to know how many drips per minute should the patient receive. Okay, so if I'm going to figure out drips per minute, first let's take what we already know. So we already know that 15 drips per milliliter is going to be our infusion set. Anytime I have drips, I go ahead and pull that out as my given. That's the IV administration set delivers 15 drips per milliliter. That is talking about the diameter of our IV tubing. So our IV set is 15 drips per milliliter. I need to know how many drips is going to be in 100 milliliters, okay? Because that's how much solution is in our bag. When I cross multiply, I get 1,500 drips. I'm going to be infusing that. Okay, so I take our 1,500 drips, and when we look back over here, that is going to be how many drips is going to be given in an hour. So 1,500 drips is going to be given in 60 minutes because we looked it up and we said that if this 100 milliliters is going to be equivalent to 1,500 drips now because of the tubing we're using, my book says I need to give it over an hour. So 1,500 drips will be given in 60 minutes or 1 hour. I want to know how many drips per minute because that's what it's asking us to solve for. So I would cross multiply and I would get 60x equals 1,500. And when I solve for that, I get 25 drips per minute. So that's going to tell me how much medication my patient's going to get per minute. Okay, look, I was looked at my answers and thought I skipped number 12. 2 different types of insulin may be required to control glucose levels. To decrease the number of injections a patient receives, it's possible to mix both in a single syringe. The nurse must properly prepare 12 units of regular insulin and 30 units of NPH insulin. List an order of technique. Okay, so we know that our 12 units of regular insulin is going to be short-acting insulin. 30 units of NPH is going to be our intermediate acting. So we need to know how we draw that up. So we need to know that we inject air into each of those syringes and that we draw up insulin from each of those syringes. And I'm going to let you guys look this up. And in fact, ATI has a wonderful video. It's in the skills tutorials about drawing up insulin. So I'm going to let you guys look that up. And this could possibly be a question you would see on the test. So you need to know in what order you would do that. So in what order would you inject air into the bottles, and in what order would you withdraw insulin? And I want you to watch that video. So let's move on to number 13. Number 13 says a physician desires the patient to receive normal saline at 100 milliliters an hour. So if I'm using an administration set, again an IV tubing, that the diameter is 20 drips per milliliter, okay? How many drips per minute should be regulated? So in this case, I'm going to take my given, and my given in this situation is I know that 20 drips per ml, again, like I said, if you're dealing with tubing, if you're dealing with drip tubing, pull out that equation you know about your drip tubing. That's your given. So I take my 20 drips per ml, and I want to know how many drips is going to be in this 100 milliliters I need to give. So when I cross multiply, I get 2,000 drips. That 2,000 drips, again, we plug that in here, is going to be over an hour. So this 2,000 drips I know is over an hour or 60 minutes. I need to know how many drips is going to be in one minute. Sorry, I couldn't read my handwriting. How many drips I'm going to give over 1 minute. So when I cross multiply, I get 60x equals 2,000. And I solve that, dividing 60 into 2,000, I get 33 drips per minute. So that'll be my answer. Number 14 says ciprofloxacin 400 milligrams is going to be added to 200 milliliters of D5W, again another type of IV fluid. And that's what's been ordered. The pharmacy recommends an infusion rate of 200 milligrams per hour with an IV pump. How many milliliters per hour should be infused? So with this one, what's our given? We know our given is our infusion rate of 200 milligrams per hour. I already know that I'm going to be giving 400 milligrams of medication, and I need to know how much of that I'm going to give per hour. So we know our milligrams per hour. I need to figure out milligrams per hour and then figure out the milliliters from there. So I take my given, my 200 milligrams per hour, I plug in 400 milligrams, and how many hours would that be given? And that would be given over 2 hours. So then I take 200 milligrams given over 2 hours equals X milliliters per hour. So when I cross multiply, I get 2x equals 200. X equals 100 milliliters per hour. So I'm going to go back and where I plugged in the 200 milliliters per 2 hours. We figured out the 2 hours, and then we know that we need to give that medication, the 200 milliliters over 2 hours. So finding out from there how many milliliters per hour, again, to plug in to my IV pump, because the pump needs to know how many milliliters per hour. So I would program the infusion rate at 100 milliliters per hour, and then the volume would be 200 milliliters. So it would know if I had 200 milliliters infusing at 100 milliliters an hour, it would take 2 hours for that medication to be delivered to my patient. So let's look at number 15. Number 15 says, at 8 o'clock, 1 liter of IV fluid was infusing at 100 milliliters an hour. At 12 o'clock, the nurse observes that only 500 milliliters remain. How many milliliters should have infused at this time? So it looks like maybe our pump wasn't programmed right or something like that, and we're trying to figure out what should the amount of infusion have been rather than what it was. So I would automatically go ahead and change that 1 liters again to 1,000 milliliters because we need to have equivalent units. So my given at this time, I know my infusion rate was 100 milliliters per hour. And I need to figure out how many milliliters has infused over those 4 hours. Because I'm taking 8 o'clock to noon, that's 4 hours. So if it was supposed to be going at 100 milliliters an hour, over those 4 hours, I should have infused 400 milliliters instead of what looks like that I've infused 600 at that time. So my amount that I should have infused would be 400 milliliters an hour. Does that make sense? If I come across any of these and the explanation doesn't quite explain it to you, or you have any additional questions, just please send me an email and I'd be happy to explain that to you, or you can stop by my office anytime. Number 16, an infusion of 500 milliliters began at 10 o'clock to infuse in 4.5 hours. At 12:30, only 150 milliliters have infused. Keeping within the 4.5 hour schedule, recalculate the flow rate in milliliters per hour using an infusion pump. So what it's saying here is, excuse me, that I needed to give 500 milliliters of IV fluid over 4.5 hours. And I started at 10 that morning, but at 12:30, so 2.5 hours later, I looked and only 150 of it have infused. So if I want to get the rest of it delivered within that 4.5 hour schedule, I need to figure out how much of that bag is left. And in order to get that infused in the following 2 hours, which is remaining from 10 to 12:30, how fast do I need to get that to run on the pump? So first, let's take what we know. We know that we had 500 milliliters and 150 had been infused. So if I take 500 and I subtract 150, that's going to give me how much fluid I have left in that bag, and that's 350 milliliters. Then I need to know how much time I have left. So I take that 10 o'clock to 12:30, that's 2.5 hours. And if I wanted to give over 4.5 hours, that leaves me 2 hours remaining. So I know that I have 350 milliliters I need to infuse over the next 2 hours. So I need to know how to set my pump. How many milliliters per hour? So I'm going to cross multiply, and I get 2x equals 350. I divide and I get 175 milliliters per hour. So that's where I'm going to set my pump at to get that infused over the next 2 hours. 17. An infiltrated IV with 625 milliliters remaining to infuse started at 2:30 p.m. to run at 125 milliliters an hour. When would you expect the infusion to be complete? So if in this case, if we had our given, which is 125 milliliters per hour, we're going to take how much fluid that we had, 625, and I need to know how many hours that should have infused. So I would cross multiply and I get 125x equals 625. So in order for that fluid to go in at 125 milliliters an hour, I need to give that over 5 hours. So, but what the question's asking me is what time would I expect that infusion to complete if I'm starting it at 2:30 in the afternoon? So I know I need to get over 5 hours. I would take 2:30 p.m., which in military time is asking for is 14:30. You need to be familiar with military time. So 14:30 plus 5 hours is going to be 19:30. So 19:30 is when we would expect that infusion to be complete. Number 18. Potassium chloride 40 milliequivalents is added to 1 liter of normal saline, and it's given as a continuous infusion over 24 hours. So it's running continuously over 24 hours. The recommended safe dosage for our patient is going to be 1.5 to 1 milliequivalents per kilogram per 24 hours. What's the daily dosage range for our patient if they weigh 144 pounds? So first what I would do is I would change that pounds to kilograms, and I work that out. That would equal 65.5 kilograms. So that, again, that 144 pounds, when we work that out, would be 65.5 kilograms. Once I get those kilograms, again, I can plug that back into my equation, and I'm going to look at a range here. So that's 0.5 to 1. That's a range of a dosage of medication, a safe dosage of medication. So I need to figure it out twice. I need to figure out if I gave it at 0.5 milliequivalents over 24 hours and at 1 milliequivalent every 24 hours. And that's going to give me a safe range. So first I would take that 0.5 milliequivalents and I would multiply that by my kilograms, which is 65.5 kilograms. And it gives me 32.75 milliequivalents. I then take 1 milliequivalent and multiply it by my 65.5 kilograms. That's going to give me 65.5 milliequivalents. So that's going to be our range over 24 hours. Number 19. The physician has ordered amoxil, which is an antibiotic, 125 milligrams per kilograms per dose, to be given by mouth 4 times a day. The medication label, which comes on our bottle of medication from the pharmacy, says amoxil is concentrated in this bottle of medication at 500 milligrams per 2 ml. So if my patient weighs 33 pounds, I need to figure out how much medication I'm going to give, and I need to figure that out in teaspoons. So we can do this. It's just a couple of different steps we have to go through. So once again, I see that I'm dealing with pounds and kilograms. Change those pounds to kilograms right away. 33 pounds, I figure that out to equal 15 kilograms. Plug that back into your equation. So 125 milligrams multiplied by 15 kilograms is going to be 1,875 milligrams per dose. And make sure when you're working out your equations, you're labeling everything, because you're going to end up with numbers with no labels, and you won't know if you've gotten to your final answer or what that number means. So label everything. So once I get that 1,875 milligrams per dose, then I need to figure out how many milliliters that's going to be. So I'll take my given, which I know from the pharmacy is 500 milligrams per 2 ml. And I need to know if I need to give 1,875 milligrams, how many milliliters is that? So I cross multiply and I get 7.5 milliliters per dose. So that's the dosage of medication, but I'm looking for teaspoons. So at this point, I have to remember that there's 5 milliliters per teaspoon. That's one of the conversions that you're going to have to memorize. So if I know 5 milliliters is 1 teaspoon, and I need to give 7.5 milliliters, how many teaspoons is that? That's going to equal 1.5 or 1.5 teaspoons. Okay? Number 20. A patient weighs 132 pounds. A physician orders Primzol 20 milligrams per kilogram per 24 hours, divided every 12 hours. Calculate the dosage of Primzol. Again, another one that I've got pounds and kilograms. Get rid of those pounds. 132 pounds we figured equals 60 kilograms when we cross multiply. Plug it back into your equation. 20 milligrams multiplied by 60 kilograms. It's going to give us 1,200 milligrams per 24 hours. But is that what we're looking for? We know that we're going to give that in divided doses every 12 hours. So if I know that I have 1,200 milligrams in 24 hours, I need to know, how much I'm going to give over 12 hours. So I cross multiply and I get 600 milligrams every 12 hours. Okay? And that's going to be my dosage. 21. The physician has ordered Pepcid. The physician has ordered Pepcid 20 milligrams IV piggyback at bedtime to be mixed in 100 milliliters of D5W and infused over 15 minutes. It's available in a 4 milliliter ampule containing Pepcid 10 milligrams per milliliter. So an ampule is a glass container that the medication would be distributed in, a little glass bottle. So this 4 milliliter bottle contains 10 milligrams per ml. So our first question is asking, we have to calculate the dosage of medication to be withdrawn from the ampule. So when we look at what we already know, we know our given from the pharmacy on the bottle is 10 milligrams per milliliter. I know I need to give 20 milligrams. So when I cross multiply that, I know I need to give 2 milliliters of medication to equal that 20 milligram dosage for my patient. The second one says calculate the flow rate if I'm going to prepare that to be given in an IV piggyback administration using an infusion pump. So I'm going to take that medication and mix it with my 100 milliliters of normal or D5W. I'm going to put that medication, that 2 milliliters, in that IV bag. Again, what I mentioned earlier is that 2 milliliters does not change the volume of fluid in that bag. It's a very minute amount. So we're still calculating for a 100 milliliter bag even after I put that 2 milliliters of Pepcid in there. So I know that I'm giving 100 milliliters over 15 minutes. I need to know how much I'm going to be giving, how many milliliters of that bag, once that medicine's in there, how much am I going to give over 60 minutes, simply because that's how I need to program the IV pump, how much per hour. So when I cross multiply, I get 15x equals 6,000, and dividing that 15 into 6,000, I get 400 milliliters per hour. So that's what I would program the IV pump at, 400 milliliters per hour. Remembering that the dosage of medication is going to be 100 milliliter bag. So if I'm giving it at 400 milliliters an hour and there's only 100 milliliters in that bag, it's going to be infused in 15 minutes. It's going to be completed. 22. Bactisil 500 milligrams in 50 milliliters of D5 normal saline. So again, that medication is being put into a bag of D5 normal saline IV fluid, and we're going to give that in an IV piggyback every 4 hours via the IV pump over 10 minutes. So the difference between a continuous infusion and a piggyback medication is continuous infusion, we've talked about, is usually a larger amount of fluid, and it's given continuously over usually 12 to 24 hours. An IV piggyback is a medication that's in a smaller volume of fluid, and it's given in a very short period of time, usually once to multiple times per day. It's not given continuously over the day. So with this one, we know that 50 milligrams is in 50 milliliters. But I need to know how I'm going to calculate the flow rate. So I'm going to take my 50 milliliters, that's the volume of fluid in my bag, and I know I want to give it over 10 minutes, but to program the pump, I need to know how much is going to, how many milliliters per hour or per 60 minutes. So I change that hour to 60 minutes because we're dealing with 10 minutes. We have to have equivalent units, cross-multiplied, and I found that in 60 minutes, I'm going to give 300 milliliters of fluid. So again, we would program our pump at 300 milliliters an hour of our flow rate, and then we would put our volume in at 50 milliliters. So we would know that that medication is going to be given at that rate, and it would be infused over 10 minutes. 23 says ertapenem, which again is another antibiotic, 1 gram is infused or put into a bag, a 50 milliliter bag of normal saline. So it's only going to be given 1 time per day prior to a surgical incision. So it's an antibiotic that's going to be given right before the patient goes to surgery, kind of a prophylactic antibiotic. We know the drop factor is 10 drips per milliliter, so that's the diameter of our tubing, and that's going to be given on the package of tubing. That's a given. We're going to infuse that medication over 30 minutes, so I need to calculate the flow rate. So again, the first thing I pull out from that is going to be that drop factor of that tubing. That's my given. That's 10 drips per milliliter. I need to know how many drips is going to be in 50 milliliters because that's how much is in my bag of fluid. So when I cross multiply, I get 500 drips. So 500 drips is going to be equivalent to that 50 milliliters. I take that 500 drips, and I know I'm infusing over 30 minutes. But for the pump, I need to know how many drips are going to be per minute. With drip tubing, we need to figure out per minute. So I cross multiply, I get 30x equals 500. And when I multiply or divide 30 into 500, I get 17 drips per minute. So that's how many drips per minute we would be giving. For number 24, I'm going to take Thorazine, which is going to be a psychiatric medication, 25 milligrams IV every 6 hours for treatment of tetanus. Literature suggests a dilution of 1 milligram per milliliter with normal saline, and administration should not exceed 1 milligram per milliliter. Again, this literature is going to be your IV drug book. So if we looked up Thorazine in there, it would tell us how much fluid we need to dilute it with and give us information such as that. We need to determine the rate in milliliters per hour because we're going to be programming it on an IV pump. So I'm going to take my volume, which is going to be, my dosage of medication, which is 25 milligrams. I know I'm going to be giving it over 25 minutes because our drug book says we're going to be giving 1 milligram per milliliter. So 25 milligrams would be 25 milliliters. So 25 milligrams over 25 minutes. So 25 milligrams in 25 minutes. That's the administration it shouldn't exceed. So then we know we want to know how many milligrams per hour or per 60 minutes. So 25 milligrams is going to be given over 25 minutes. How many milligrams in 60 minutes? We cross multiply and we get 60 milligrams per hour is how much we need to program that pump at in order for that 25 milligrams of medication to be given in 25 minutes. Okay, so there's your answer key. If you have any additional questions, please feel free to email me. Since I'll be available if you want to email me, or if you want to stop by and ask me questions. So just check with me and I'll let you know a good time to come by, or if you're on campus already, you can swing by and I can go over some of these with you. So I hope that helped, and I will see you for your dosage calculation test on Monday.